Hey guys, so we are going to finally transition to a different topic. The last few weeks we have been focusing on parallelograms and squares and rhombuses and basically you name it, the quadrilateral, that's what we've talked about. We're actually going to stick a little bit with quadrilaterals today, but we're going to transition to some other topics for kind of the rest of our school year. Exactly when that ends, I don't know yet, but I'll let you know as soon as I have a final date. We're going to talk about area and perimeter throughout the next few lessons. In particular, today we're going to talk about the area and the perimeter of rectangles and parallelograms. So, just a little reminder, you guys know that you're going to get not so perfectly drawn pictures, but here's a nice basic blurry. Oh, come on, focus. There we go. I'm going to see if that button makes it. That was worse. That's better. Okay, you know my equipment does whatever it wants to do. I just kind of have to follow along. So I have a little imperfect rectangle there. I want to talk to you guys about the difference between area and perimeter. I know that you've heard those words, but we need to make sure that we understand the meaning behind both of them. So I'm going to start off with the concept of perimeter. Now, this is not the formal definition, just roll with it. The perimeter, I want you guys to think about that as the walking distance around the outside edge. You might hear some noises in the background. My dog is taking her 40th nap of the day, and she has little puppy snores happening, even though she's not a puppy. She's 3, but you might just hear a little, it's my dog, I swear, it's not me, because I don't ever stop talking. So perimeter is the walking distance around the outside edge. So that would be how many steps in whatever units we're measuring as we walk around the outside edge. And I want you to think in terms of like a fence. That's the concept of perimeter. When we think of area, that is the interior space. So when we talk about perimeter being the walking distance around the outside edge, that would be in feet or centimeters or yards or inches or whatever we're measuring. For area, we're actually talking 2-dimensional space. And the units that we would be doing would be feet squared, centimeters squared, yards squared, inches squared, etc. So the perimeter goes all the way around. The area is looking at the space inside. So when you think about area, I want you to think about carpet or grass or tile or having to paint something. Or, I don't know, if you're making a poster, perimeter would be having you measure the edge around it to create a frame. The area would be how much do you have to color inside the poster. So those are just kind of the two concepts. When we think about the area of a rectangle, it's actually pretty simple and basic, depending on the information that you're given to start with. So the area of a rectangle, we're going to have our base and our height. Put that up for you guys a little bit. So area will be base times height, 2 different dimensions. That's why it's going to have a quantity squared. And you might be wondering, I'm going to have to switch to a pen because I am now out of lead. Great. So you might be wondering, well, how do I know which is which? Well, what matters here in a rectangle, the 2 heights are going to be the same because they're congruent, and the 2 bases are going to be the same. So as long as you have 2 lengths that create the right angle, you're golden. Now you might wonder about a square. You might wonder if I could spell the word square. So a square is just a specialized rectangle where all the sides are the same. So if you know one of them, then it's that length squared because all the lengths are the same. So typically we write it as side squared because all the sides are congruent. When we talk about the area of a parallelogram, now this is where I wish we were in class because then we could kind of like cut it and draw it and make sure that it works. So remember my parallelogram, when I draw those, it looks like just a nice, beautiful, slanty rectangle. So when we talk about area for the parallelogram, it looks just like the area for the rectangle. It's base times height. But we have a problem here because on a parallelogram, we don't have a guarantee that we're going to have two perpendicular sides. So what we have to do is we have to create a height inside that parallelogram. So we're going to drop from one parallel side to the other the length of that height, that distance, and we're going to drop in a perpendicular. So that's where our height comes into play, and then our base is this whole distance. And if you're wondering, well, how does that work? Well, let me show you. I'll color code it for you guys. If we were to take a look at this particular triangle, and I was to sketch it over here, hey, look at that. It forms a rectangle, base times height. So it's the same area, the same space that we're looking at. We're just cutting, flipping, and pasting it to show you that we're looking at the same thing. We just have to make sure that we have a base and a height happening. So on today's assignment, we're actually going to be doing problems out of the book. I know, it's crazy. But instead of doing a worksheet, partly because I don't have one made up, and the book assignment is pretty dang small, I'm going to walk you guys through a couple of examples. In the book assignment, you're going to have 1, 2, 3, 4, 5 questions. So I'll try to keep my examples pretty close to that. My examples are going to be pretty dang similar. Of course, you know, different numbers, but that's how this thing kind of plays out. So, giving myself some new space. I'm going to start us off with 2 questions. We need to find the perimeter and the area. Once this focuses, please focus. I'll get it to focus in a second. I'm going to keep going with my drawing of this particular shape. Now I'm going to tell you that this is a parallelogram, and now you can see that it's a parallelogram. So I'm going to provide you some different pieces of the puzzle. Let's see. I'm going to tell you that this guy is 3, and that one is 2. And then I'm going to do a perpendicular height. And I know you can't see it because it's trying to focus. You don't have to take that perpendicular from that vertex or that corner. It's going to be the same height all the way through because in a parallelogram, they're parallel, so they're going to be the exact same distance all the way around. So I'm going to claim that this guy is 1.5. And I'm going to label everything as feet. Those units matter. And again, I'm sorry my equipment won't stay focused, but hey, it hates me. So here we go. So let's talk about the perimeter. So I'm going to use my highlighter as I go around. We don't have all of the information written down in our examples, but we have everything we need. That guy's going to be 2 because these are parallel congruent sides, and this bottom piece is going to be 3 once it finally refocuses. So when we take a look at our perimeter, oh, for goodness sake, stop it. I'm 8 minutes in, guys. I'm not redoing this video. Just bear with me. When we talk about finding our perimeter, we're going to add up the outside walking distance. So 3 plus 2 plus 3 plus 2, that makes 6, 10 feet. For our area, we're going to do base. Now our base is the 3, and our height is the 1.5 because that's where the perpendiculars are connecting. And 3 times 1.5 happens to be 4.5. And notice how I'm going to label that as feet squared. Not so bad, right? We can do that. That's totally doable. So hopefully that makes sense so far. We're going to take a look at another problem in our notes that's going to be very similar to a problem in the book. This is actually called a composite figure. So when we talk about a composite figure, it's not necessarily going to look like a rectangle or a parallelogram. It's going to look like pieces put together. So you know how well I draw. You know my equipment hates me. Let me just get some stuff drawn. Not drawn to scale. Okay, people? Not drawn to scale. So I'm going to tell you this whole distance is 8 feet running across the entire top. I'm going to tell you this guy is 2 feet. Over here on the side, we have 7. Totally not drawn to scale. I know you can't see it. Just let me keep going. And I'm going to tell you that this distance is 6 feet. Okay, hopefully it stays happy. So our task is to find the perimeter and the area. Well, we don't have all the information that we need, so we're going to have to kind of do some logical steps. If we know that this distance is 2, I think we can tell that this distance is also 2. And this whole length is 7, so I'm going to scribble that out. I'm going to put my 7 feet over there. It'll clear up in just a second. If that whole distance on the left-hand side is 7, and we've used 2, then right below that is 5. So 7 less the 2 gives us the 5. Kind of the same concept here. This whole distance is 8. We've used 6. 8 minus 6 means this is 2. We can now find our perimeter. So if we add everything up, I'm going to start here at the 2, and I'm going to go this direction. 2 plus 8 plus 2 and 5, which was the 7, plus this 2, plus the 6. So again, 2, 8, 2, 5, 2, 6. Let's see, 2 and 8 makes 10. 2 and 5 makes 7. 2 and 6 makes 8. 8 and 7 makes 15 plus 10. We have 25 feet for our perimeter. Now in terms of the area, when we go through to find our area, we're going to have to break this up into shapes that make sense, shapes that we can find the area of. I'm hoping that you guys see 2 different rectangles happening, and there's different ways you could split it. I could split it right here into this top skinny rectangle and then the bottom kind of leg, or I could break it into a left-hand rectangle and a right-hand piece. It really doesn't matter. So I'm going to take my highlighter and I'm going to break it right here. So I'm first going to find this area in pink. That's a nice rectangle. It has base of 2, height of 7, so I'm going to highlight that in pink, and that will give us 14 for the area of that space. And I'm going to grab my yellow highlighter. I'm now going to highlight this piece right here, where we have 6 feet by 2 feet for a total of 12 for that area. And in a composite figure, we're going to have to add the 2 pieces together. So we're looking at a total of 26 feet squared. Again, be aware that your area is going to be squared. I'm sure you guys can see that. So those are just some basics. I initially had said I was going to give you 5 problems. I'm kind of revisiting that. I'm not sure quite how many it'll be, so now it's going to be a surprise when you open up your assignment. But your assignment is going to be in section 30-1. We're headed toward page 435 and 436, and I will let you know exactly what problems I want you to do when you log into Google Classroom. I'll have it in the statement for this one. Let me know if you guys need me to upload a photo. You guys should be okay because all of you guys had your books. If you did not pick up your book the last day of our classes, I was required by the district shortly after that to take everything to the Learning Services Center, which is one of the district main buildings on Pioneer Way. Your books have been there waiting for you. Your names are Sharpied on them. And I believe I sent you guys an email stating if your book needed to be dropped off there. But let me know if you need me to upload a picture, and I can do that. Or maybe, how about this? Here's an extra credit opportunity. I'll toss out a couple of extra credit points for the first person that uploads a blank photo. Okay, that didn't come out right. A photo of your book before you write in it without any answers, if that makes sense. I'll call it a clean photo of the problems on your assignment. I can give extra credit for that. That makes sense. It works for me. Hope you guys are doing well. Take care. Bye.